Yo, what up, everybody? Today we're going to be talking about horizontally launched projectiles. These are projectiles that are launched into the air, either shot, kicked, hit, rolled, whatever, but an object is put into the air at a horizontal angle, meaning there's no initial motion going up and no initial motion going down. It just rolls off, it just goes off horizontally and then gravity pulls it down. And so with this type of projectile, I can show you how to find out all sorts of information, like how high it is, how far it's going to go, how fast it's going to go. And we're going to do this with a minimal amount of mathematics. We're going to show you how to do this the easy way. All right, maybe your teacher is giving you a bunch of equations. You don't need that many equations for this. Stay tuned and I'll show you how to do this the easy way. So, some basic physics. On Earth, if you drop something, it accelerates about minus 9.87, but we round that up to minus 10, right, for this video here. So you can think about this like every second that goes by, you add minus 10 to the vertical velocity of the object, right? Whereas horizontal acceleration is zero, which means you just add zero every second to see how fast it's going horizontally. And of course, if you add zero to something, you don't change the value. So we'll see how this comes into play. But let's look at this example first of all. Let me show you an example of somebody falling. All right, and this is gonna, and we'll have him go horizontal in just a second. All right, but to understand what happens when someone falls, all right, assuming no air resistance, or we ignore air resistance, the velocity is gonna increase by negative 10. You add negative 10 to the previous velocity every second to get how fast he's gonna be going. All right, and so you can see that every second he goes 10 meters per second faster. And that's a result of gravity. Now, what would happen if we graph his velocity versus time? Well, we get this graph right here. The slope is minus 10 because the slope of a velocity graph is acceleration. There's some important piece of information here. You have initial velocity, which is zero. His final velocity, okay, it says he spends 4 seconds in the air, so we know that every second goes by, you add negative 10 to the velocity. So he's going negative 40 by the end. But then something you might not think about, but it's actually really important, is the area of this graph. You see this graph makes kind of a triangle. Well, the area of this graph actually equals the displacement, right? And displacement, when we're talking about vertical motion, is just height. So the area of this triangle is actually how much he fell, which is going to tell us the height of the cliff. So the area of a triangle is 1/2 base times height. All right, and if you plug in all these numbers, there's a 4 here, a 40 here, you get negative 80. So if he went down, negative just means he went down. He went down 80 meters. How high was the cliff? The cliff had to be 80 meters high, right? So without any fancy formulas, we're able to find that. Now watch this. What happens if he has a skateboard and that he rolls off, and let's say that the edge of the cliff is horizontal, so he rolls off horizontally. You'll see that at his time, zero, his vertical velocity is zero because he's not going up and down yet, but he will soon once he goes off the edge. His horizontal velocity is 12. Fast forward 1 second. Horizontal velocity doesn't change because remember the acceleration is zero horizontally. The vertical velocity does change by minus 10, right? And then minus 20, 30, and 40. But you see the horizontal velocity doesn't change. Okay, so if we ignore the effects of air resistance, there's nothing to speed up or slow down his horizontal velocity because the only force is gravity, and gravity pulls down, not to the side. All right, and so this is what would happen to him. And now we have to keep track of two velocities, one vertical, one horizontal. And they're independent of each other, meaning the one doesn't affect the other. All right, if he had rolled off at 24 instead of 12, his vertical velocity would have still done the exact same thing. Okay, so we saw the vertical velocity graph before. We know that the area is equal to the height that he fell. Now we have the horizontal velocity, and that's just a flat line because it's not changing. It's 12 the whole time. But the area of this graph is going to equal how far he is from the cliff. And you can see that this graph is just a rectangle, right? And so we got 80 meters for the height of the cliff. Now all we have to do is find the area of this rectangle here for vertical velocity, which is just base times height, 4 times 12. And so the area is 48, which means he landed 48 meters from the base of the cliff, right? So just by some basic geometry, we're able to figure out how high the cliff was, and how far he got away from the cliff by the time he hit the water, right? And so we know this if we know the initial velocity and we know the time. Now you might ask yourself, how fast is he actually going, right? Because he has two velocities here. He's going 12 meters per second to the right, 40 meters per second down. What if you just want to know how fast he's going, period? Well, think of these two values, his horizontal and vertical velocity, as two sides of a triangle, right? If we want to find the total, we can't just do 12 plus 40, right? We have to treat it like it's a triangle and we're trying to find the hypotenuse. And so you actually use Pythagorean's theorem to find this, all right? And then, so here it is right now. His actual speed is going to be, you like square this and square this, add them together and take the square root. All right, so this does take a little math, but with a calculator, this shouldn't be too bad. And you can see his actual speed is 41.76 meters per second. His speed should be greater than his vertical, greater than the greater of the two numbers, right? But less than what you get if you add these together, right? So without doing any of the math, I could have told you that his speed is greater than 40, but it's less than 52. Okay, and that's how fast he's actually going when he hits the water. Now, if you're asked to find out like what direction he's going, you need an angle, right? Maybe your teacher asked for this, maybe they don't. But basically, you'd have to do a little trigonometry, right? You see you have two sides of this triangle here. You want to find that angle. You would use inverse tangent, opposite over adjacent. All right, put those numbers in, and you get that this angle is negative 73.3. All right, so you just have to use that, put it in a calculator to get this. All right, so with the minimal use of mathematics, we were able to find the height of the cliff, how far he goes, how fast he's going when he hits the water, and the angle at which he's going to hit the water. So hopefully this was interesting. Hopefully this helps you, and I hope to see you all in another video.